Okay, for example 13, we're looking at a trinomial. Anytime you see a trinomial, you want to start thinking immediately quadratic. And I touched on this yesterday briefly, about being quadratic in form. To be quadratic in form, three things have to be there. We have to have a constant, okay? So it has to be just a number. There has to be some power of x and double the power of x. If you have that, you're quadratic in form. It'll factor like a quadratic equation, or a quadratic polynomial will factor. The two numbers that multiply to make -8, that add to make +7 will be 8 and -1, right? So you find your two numbers, and you put your two parentheses. You can put a +8 in one and a -1 in the other. All right? Then, whatever this guy is on your middle term, the smaller power of x, that's what goes in front of each of these guys. Okay? And if it were a nice book, that would be the end of the problem. All right? It does say completely factor, and it seems like we've done a good job of factoring. We pat ourselves on the back that we know what we're doing and did the quadratic by form thing. But notice the two factors here. X cubed plus 8 is the sum of cubes. X cubed minus 1 is the difference of cubes. So now we can factor those beyond that level. So notice x cubed plus 8, the cube root of x cubed is x, the cube root of 8 is 2. And we're going to put plus because that's the sign in there. The second parentheses is always going to be the first object squared, the two objects multiply the second object squared. And the signs go same, opposite, plus. The second thing, x cubed minus 1, the cube root of x cubed is x, the cube root of 1 is 1. We square x, we multiply the two things together, we get x, we square 1, we get 1. We want the same sign negative, opposite sign plus, and last sign always plus. At this point, we have x's to the first power, which are good. These here, from a cubic, just x to the third power, they never factor again. Okay, those, if you tried to factor those, you'd get imaginary roots, and so they're not factorable. But if the power is higher, like it's x to the 6th, x to the 12th, that kind of thing, it's a possibility it would factor again, and we'll deal with that, I think, in the homework. And I talked to both of you earlier about this, and if anybody watched the video. Anytime you have a binomial, always look for difference of squares first, sum or difference of cubes second. Always do difference of squares first, and then it'll be something more like this where they both factor out like this. So keep that in mind in case it should happen.